Hello everyone, welcome back. I'm Math Boy. Today we're going to be talking about conics off-origin. We've done hyperbolas, we've done ellipses, we've done parabolas, and I sort of mentioned circles. But now we're going to be combining it all and moving it all off the origin. So I have all of our equations that we've learned so far right here in this little box that I just made. And basically, if you remember from when I was deriving the ellipses equation or the parabola equation, I got rid of the hk, the h comma k, or the x minus h, y minus k, because they just weren't needed because they were always going to be 0 and it wouldn't affect the equation. But now we need them because they will not always be 0 from now on. So every equation, all we have to do to change them is add a negative k to the y's and add a negative h to the x's. So our equations turn into y minus k squared equals 4p x minus h, and we get x minus h squared equals 4p y minus k x minus h squared over a squared plus y minus k squared over b squared equals 1, and finally x minus h squared over a squared minus y minus k. I don't know what I just did. It's supposed to be a k, not a whatever I made it. Y minus k squared over b squared equals 1. And then h comma k, oh my gosh, I did it again. I'm gonna not do that next time I write k. H comma k is the center. There's not really much else we're gonna learn. I'm gonna sort of teach some stuff in some examples that I do later, but that's pretty much all we're gonna learn for now. Now I'm just gonna do a bunch of examples. Hopefully you'll learn something, and if not, I hope you get some problems. Okay, so now we're gonna graph this equation. That last number is a 7, by the way, just in case you're wondering. But if you can tell me what this is right now, then I'm proud of you. Take that. If you can't, it's a parabola, and I know that. It's sideways. I know that because there's only one term being squared. There's no x term being squared. And because the y is being squared, if you look at our standard equations, the sideways one had the y squared, not the one that's up and down. So now we're going to complete the square to get the standard form of this equation and get it to a point where we can graph it. So let's go y squared. I'm going to get all the y's together and all the x's and the constant together. So now if you remember how to complete the square, it's not that tricky. I'm not going to explain it, but basically you divide the coefficient of this term by 2 and then square it. So y squared minus 2y, and then negative 2 divided by 2 is 1, negative 1, squared is 1, so plus 1, then add it to the other side equals 8x, plus 7 plus 1 is 7 plus 1 is 8, so it's plus 8. And then I'm going to factor each of those, and using our patterns, get y minus 1 squared equals 8 times x plus 1. If you need help with factoring, you shouldn't be watching this. You should be watching a different video. So now that we have this, that's our standard equation. We're good. We can tell that this is 4p, which means p is 2. H comma k, h is negative 1 because this is minus h, so 1 equals negative h, h equals negative 1, so it's going to be the center of negative 1, comma 1, because this is minus k, and then minus 1 minus k, k is 1. So that's our center. It's our p-value, and I know it opens this way because p is positive, and like I said earlier, it's sideways. Because the squared is over the y and not the x. And it opens to the positive side if the p is positive. So now we're going to graph this. You don't have to graph the directrix if you remember that, but I think I will. 4, 5, 1, 2, 3, 5. Okay, so center negative 1, 1. P-value of 2, opening right, so that's 2, that way. Focal width, if you remember, is right here, the 4p, back in our standard equation, that's where I am. I'm highlighting, underlining this. 8, that's our 4p, but that's on both sides, so divided by 2 is split evenly among the sides, that's 4 on each side, so 1, 2, 3, 4. 1, 2, 3, 4. And the directrix, I'll draw it. That's P behind the center. So that's 1, 2. That's the directrix. And then go ahead and graph this. Sorry, my graphing's not very good. And so that's our sideways parabola, and I'm going to do one that's an up and down parabola. Okay, so this is our sideways parabola standard equation. If you can't figure that out on your own, you know because the x is being squared and the y isn't. And we just look back at our standard equations like we did for the last one. But anyway, what we're going to do, like last time, is move the the variable that's not being squared and the constant to the right side, so we get x squared plus 4x equals negative 12y minus 52. And then we complete the square on the left, and the pattern, I'm not going to review that because it's sort of late at night, I don't have time, is divide by 2 squared, so 4 divided by 2 is 2, squared is 4. 4 is that number that works out like that because 2 times 2 is 4, and 2 squared is 4, and all of that. 2 plus 2 is 4. Okay, so now we have this. We can factor on this side, so we get x plus 2 squared equals. Then we need to factor out something. And I'm going to tell you right now, I don't know off the top of my head if 52 is divisible by 12. Actually, it's not. So, that's nice. Oh, wait, actually, we forgot something. We forgot to add the 4 to both sides. That is very important. See, because I added the 4 here, I have to add the 4 here. So I get negative 12y minus 48. Okay, I know 48 is divisible by 12. So I'm going to get negative 4. What? No, that's not good. Because I'm factoring out 12. 4 is going to be the remainder with the negative 48, but I'm factoring out the 12, so negative, whoa! 12y plus 4, and we just erase that random line. So if I ask you to find p, negative 12 equals 4p, divide the whole thing by 4, p equals negative 3. So p equals negative 3, and the center is negative 2, negative 4. I know that because h minus k and x minus h and y minus k. So we just make this negative for the x value of the center and this negative for the y value of the center. So now let's graph this. We're probably going to need a bigger graph than last time. 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this one's a little bit of a bigger graph. It's fine. I probably should have counted by 2's, but that's also fine. -2, -4 is going to be right there. And then p is -3. Because it's negative, it opens downwards, and already established that's up and down earlier. So 1, 2, 3. And then focal width, the whole thing is 12 because you can't have a negative length. Divided by 2 for each side, so you can split them evenly. You get 6. So that's 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. And then directrix, we don't have to draw, but that's 1, 2, 3, like that. 3 away from the focus. The directrix is positive p away from the focus. That's how you find it. Now, parabola is something like this. Obviously, I can be better at graphing, but I'm not. Handwriting's just really bad. But that's it for the parabolas. We're going to move on to either a hyperbola or an ellipse. We're going to figure that out. I'm going to tell you. Okay, so now we have this big ol' equation. I can tell you right now, it's either an ellipse or a hyperbola, because the x and the y are being squared. So let's rewrite this. I'm going to put everything on one side just together. So I'm going to have -9x squared plus 54x. And I'm going to factor stuff out later. Plus y squared minus 2y equals 80,9. Okay, so obviously well, I don't know if this is obvious for you, but for me, it's obvious that one of these are going to be easier to complete the square for. So I'm going to do the harder one first. It's going to be -9, because x cannot have any coefficients. X squared minus 6x. I think that's right, yeah, because I remember making this and it was 6x. Okay, and then I'm just going to put a plus blank plus y squared minus 2y plus blank, double underline it, equals 89 plus blank plus blank blank. Because remember, you have to add it to both sides. Actually, I'm just going to underline this 3 times because it's not the same thing as this blank. So now, basically, divide -6 by 2, square 3, so this is 9. But you have to remember that it's -9 out here applies to the 9 in there. So really, before we took out the -9 of that whole thing, it was -81, then we took out a -9. So -81, that's what we're going to move over, not 9, that's why I triple underlined it. Then y squared minus 2y divide -2 by 2, that's 1. -1 squared is 1, so it's going to be a 1. That's going to be a 1. I got 89 minus 81, that's about 8, plus 1 is 9, right? I'm good at math, I promise. And then I'm just going to do -9x minus 3. I hope you're squared. I hope you're okay with me doing that in my head. Plus y minus 1 squared. That's equal to 9. So I'm going to divide the whole thing by 9, because if you remember, we did actually do this last time, to get negative x minus 3 squared plus y minus 1 squared over 9. But there's a little problem I have with that negative. In our standard equation, it was something minus something, not negative something plus something. So if I just equals 1. If I rewrote that equation, I'm going to write it in this top corner. I would move the y minus 1 squared over 9 to the front. So I get y minus 1 squared over 9 minus x minus 3 squared. You can imagine that's an over 1 there. You don't have to. Equals 1. I'm going to clear this whole board, and then we're going to graph it. Okay, we have our graph. We have our equation. We're going to do something with that equation to move it onto that graph to model what the x and y values are. That's the whole idea behind graphing everything. And so let's identify a few things. A is always first in the ellipses. I mean, hyperbolas. I did this last episode. Okay. So that's a squared. So a is 3. This is b squared. So b is 1. A squared plus b squared. Because this is a hyperbola. I don't know if you know that by now because that's a minus. A squared plus b squared. 9 plus 1 is 10. Square root of that is c. So c equals root 10. And let's see, is there anything else we should identify? Yes, the center. So x minus h, x minus 3, h equals 3, y minus k, y minus 1, k equals 1. So that's 3, 1 for the center. And of course, the hyperbola doesn't actually touch that point, either with the ellipse if that was the center. So let's just graph this. 1, 2, 3, 1. A. So is this up and down or left and right? It's up and down because the A is under the Y value, or the Y value is first, because the A is always first. So whatever's first will be over the A value. But because the Y value is first, it's up and down, or you can think of it that the A is under the Y value, so it's up and down. But 1, 2, 3, because A is 3, so that point's actually on our little hyperbola. Down, 1, 2, 3, so it's that point. Let's also graph the co-vertices just so we can imagine our box that I talked about in the last episode. If you haven't seen that, go ahead and check it out. B is 1, move 1 over this way, 1 over this way. And then we technically could graph C. We don't need to. If this was an actual math test, your teacher would want you to. So I'm just going to do it. So square root of 10 is about 3 point something. 3.1 or 3.2. So down from the center, it's 1, 2, 3 point a little bit. 1, 2, 3 point a little bit. Sorry if that's not apparent, that's just a little bit, not a whole number. And then focal width, 2b squared over a, so that's 2 times b squared, which is just 1, so 2 over 3, that's the focal width. Right? I'm doing that right? Yeah. So 2/3, divide by 2, so times 1 over 2, that's 1/3 on each side, so wow, this is really not very pretty. I mean, it's not a square root, so I guess that's something, but besides that, it's not very pretty. And then we could also do the find the asymptotes, and on tests you will likely have to find the asymptotes, you'll just have to find the equation of that by plugging in points. Or you could just leave it in slope-intercept form. I don't know if your teacher would let you do that. But basically, on the corner of the box, draw it like that. Corner of the box, draw it like that. Boop, boop. Corner of this little box. And if you haven't seen the hyperbola video, once again, I highly recommend you go watch it. You'll understand what I'm talking about better right now. And so basically, the two ways we can just, not two ways. Two ways we could do, actually, yes, two ways we could do this is running it along the asymptote, or just using the points on the focus, focal width. I'm using both so that you see that you can do both at the same time. And that is all it is for the hyperbola. We're going to graph one more conic. I bet you know what it is. It's a parabola, obviously. And we'll be back. It's not a parabola. It's an ellipse. I'm sorry if I called this at any point an ellipse. I don't know why I keep doing that. Okay, final equation. You can do it. The video's almost over. This one's the most intimidating one I made out of all of these. And it's nice that we're doing it last. So we're going to end on one that we're all going to struggle with for the rest of our lives. That was a joke. We're going to rewrite this into a more convenient form, 96x. I'm going to move the constant over to the side with the not variables, plus 25y squared minus 200y equals negative 144. Okay, so now 96 is divisible by 16. We're happy. We're happy campers. If we factor out a 16, we get x squared minus 6x, and I'm just going to add a plus blank. If you saw the last example, you already know what that is, because it's the same blank as earlier. But if you just skip to this, you don't. Then plus 25. 200 is also divisible by 25. How lucky can we get? Y squared minus 8y plus blank. I'm not going to do the double blank underline thing anymore. Equals negative 144 plus blank plus blank. Okay. Oh, sorry. Doing something. Doesn't matter what. So, we're going to figure out what each of these blanks are. And I'm not going to explain this. I already said this like 3 times. I'm not going to explain it. Negative 6 divided by 2 is 3. Squared is 9. So, 9 goes here. Negative 8 divided by 2 is 4. Negative 4. 4 squared is, negative 4 squared is 16. And then we have to apply the 9 to the 16. 9 times 16. Okay, I'm just going to be honest with you. I don't know what that is off the top of my head. Yes, I have to do this. What? This is working out perfectly? Don't those just cancel out and we just get blank on this side? Okay, so 16 times 25. I bet it's going to be something that 25 and 16 can go into. And I actually... Should I write it out? Yeah, I'll write it out. I mean, I already know what this is. But you don't, unless you do. That's 15, 0, 2, 5, 400, because you add this together. We're not doing multiplication. This is not a multiplication video. If you need one of those, I'm not the one to ask. I do Algebra 2 videos. That's just 400 on this side. So, and I'm gonna, like, do some of this completing the square stuff in my head. 16x plus 3 squared plus 25y That's not a plus 3 because when this is negative, which means this has to be negative, so quickly erase that. X minus 3 is 25y minus 4 squared equals 400. If you've seen any of my other videos, specifically the one on ellipses, you know I can divide this whole thing by 400 and you'll know exactly what I get. That's going to be our standard equation. I'm going to erase all this again. X minus 3 squared plus y minus 4 squared equals 1. What's under each of them? Well, 16 over 400 can be simplified to 1 over 25, and 25 over 400 can be simplified to 1 over 16. Oh, how convenient. It's like I planned ahead for that. And clear the board one more time. We're going to graph it. We're going to be done. You can go play Minecraft. I don't care. What we've all been waiting for, the final test of all of our knowledge graphing an oval. Let's identify a few points. In the ellipses, the a value is always the bigger one, so a equals 5. B is the smaller one, so b squared equals 16, b equals 4. A squared 25 minus b squared 16 equals c squared. C squared is 9, c is 3. Oh my gosh, is that a Pythagorean triple? And then center is 3, 4, because x minus 3, x minus h, so h equals 3, y minus k, y minus 4, y is 4, so 3, 4. Let's graph this, and I will let you be on with your day, and I don't care what you do. Like I said, you can play Minecraft while I care after this. That's what makes me different from your math teacher. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you like this video, then go ahead and leave a like and subscribe, because, like I said earlier in a different video, this is a 20-time project. I need motivation to keep this going. It's going to end like next week or the week after that. There's not going to be very more videos. So I need encouragement to keep this thing going. But now that we're done with that, let's graph 3, 4. And then a is 5. It's up and down because the a is under the... Actually, no, not up and down. I get my ups and downs and lefts and right mixed up. I'm sorry. It's left and right because the 25 is under the x, and the x is left and right. So that's 5, 1, 2, 3, 5 this way. And 5 this way. B is 4, so it's 4 down. 1, 2, 3, 4. 1, 2, 3, 4. Could graph from that. I'm going to find the focal width. So C is 3, and it's always on the A axis on the hyperbola and the ellipse. 1, 2, 3. Focal width, 2b squared over a, 2 times 4 squared, so 2 times 16, 32 over a is 5. Well, I haven't seen that fraction before. That'll be 6.4 or 3.2 on each side. You've seen that before, I promise. It's going to be 1, 2, 3. If you've watched my other videos, which you should if you haven't already, or even watching this if you haven't seen my other videos. There's like no point. And, oh my gosh, yeah, I'm sorry, my handwriting's sort of bad. So actually putting these points in the proper spot is really hard for me. But as long as it's close enough, it doesn't really matter. That's our cute little ellipse. It would be better if I had better handwriting and better line drawing, but I don't. And that's really it. The whole conics lesson. No more conics videos. I'm gonna start doing logarithms. If you want to see that, make sure to subscribe. You don't have to leave a like if you want to see logarithms, but obviously if you've watched this far, you like the video, so I mean, why not leave a like if you're watching it right here? I'm gonna draw my derpy subscribe button. Yeah, so please subscribe. That would be greatly appreciated. I have to finish editing this video today or I'll be very upset. So I'm gonna go ahead and leave you all. Have a safe day. Have a fantastic day. And remember, math is hard for some people. But if it's hard for you, that's fine. Oh yeah, cheesy subscribe button. Bye!